Hi sir, this is P. Akila from Computer Science Engineering in specialization of CAA and ML. Today's my topic is creating tables with relationships. First of all, introduction. Introduction to the DBMS. A database management system is essential for managing data and application. It allows users to create and update, manage data efficiently. Understanding tables creation and the relationships is crucial for effective database management design. Then next, understanding tables. Tables are the fundamental building blocks of the database. Each table consists of a rows, which means a tuples. A tuples is a single record array, one row in a table. And the columns, it is also known as the attributes, where the rows represents records and the columns represents the attributes. Properly defined tables are essential for the maintaining data and integrity and organization. Here the example of the table. Then next, attributes. Attributes is the property of the entities. It represents the oval shape. And the entities. Entities is the real world concepts or the objects about which the data is collected. It represents in a rectangle shape. Then next, primary key. A primary key is a unique identifier for each row in a record in a table. It ensures that the no two rows have the same value in the primary key columns. Choosing the right primary key is vital for the establishing relationships with other tables. Here we have an example table that it has a 4 columns. The first one is the student ID, first name and the last name and the course ID. In this table, student ID is the primary key. Then next, foreign key. A foreign key is a column that creates a link between two tables. It refers to the primary key of the another table, establishing a relationship. A foreign key helps maintaining referential integrity and ensuring that the relationships between the tables and the validity. Here the example table 1. In this table 1, field 1 is the primary key. In this table 2, field 5 and field 6 are the two primary keys. Then next, understanding table relationships. First of all, what is relationship? Relationship is associated with two or more entities. And why relationships? Enabling data connectivity and the data integrity. There are some types of the relationships. First one to one, which means each record in one table corresponds to a single record in another table. Then next, one to many, which means a record in one table links to multiple records in another table. Then next, and the last one, many to many, multiple records in one table related to multiply records in another, often through a bridge table. Then next, creating a table with relationships. In this database designing, understanding and the implementing relationships between the entities is crucial. These relationships is one to and one to many and many to many. Establish connections between tables using key constraints. Now let's explore each type of relationships with examples and the SQL implementations. First one to one relationships. In this relationship, each row or the record of the the table is exactly related to the one row in a second table and the vice versa. Example, let us consider the two tables, student and the class details. And first one in a student table contains two columns, enrollment and the name, and the class details contains 4 columns, roll number, class, division and the enrollment. From this example, we can see that the student will have only one enrollment number allotted, only one roll number and the only one class and the division. Then it may change year wise of the semester wise, but a student cannot have the multiple classes or enrollment numbers or the enrollment roll numbers simultaneously. Here a one-to-one relationship occurs. Let's Understand one-to-one relationship with the help of the table diagram and their output. Then next, create a table student and the class details with the required columns or the attributes as mentioned in the above example. In these, student and the class details, enrollment numbers and the name and the roll number in a student name, and the class details contains a roll number, class, division and the enrollment. Here we can see that each student table is recorded exactly related to the one record in the class details. Each student is related from the details and it's a class uniquely. Then next, SQL query. Now to retrieve the data from the tables, we are write the following queries to the following details of the both tables. In these, select student dot enrollment number, student dot name and student dot roll number, class details dot class details dot division. From the student, we can use the inner join class details on the student enrollment number is equals to class details enrollment number. From the above query retrieves records using the primary key and the foreign key of the another table, which is in turn a primary key of the first table. The above query uses enrollment number for referencing the records for both. In this query, we retrieve the data using the primary key of the student tables and has a foreign key of the class details tables. Then next, output. In this output, through the above output or results, we can each record first table is related exactly to one another in the next table. We can also notice that one-to-one record output, no multiple records are possible. Then next, one-to-one relationship. In this definition, we saw that the one-to-one relationship. This means the class details table is also related to the exactly one record in a student table. And here these are the two tables, class details and the student. Then next, let's see the query for a one-to-one relationship from the class details table to the students table. Select class details roll number, class details class details division and the student enrollment number and student name. From the class details, inner join student on class details roll number and the student's roll number. As we see in the above query, we use to class details table primarily to retrieve the data using representation one-to-one relationship. Then next, output. Here the roll number, class, division and the enrollment number and the name. We can see that we have the same number of records that we got in the output from the table into the class details table 5 and it's the same number of the records while retrieving from the class details to the table. Now we can also see the each record associated with only one record in another table. We got 5 records from the both way of retrieving the data using. Then next, many-to-many relationships. A many-to-many relationship occurs when a single record in one table relates to the multiple records in another table. This is the one of the most common type of the relationships in database. An example is the customer table related to an orders table, where one customer can have many orders. Here it is the tables. Then next, many-to-many relationships. A many-to-many relationship exists when multiple records in one table related to the multiple records in another table. To implement this, a junction table is often used to connect the two tables. For instance, students and the course can have a many-to-many relationship where the students can enroll in many courses and the vice versa. And here are the tables team members and the projects. Then next example, consider the tables faculty and the department. Now the faculty table has consisting the faculty ID, faculty name, and the course as shown, and the department has column department ID, department name, and so on. Now each faculty member can be associated with the multiple departments, and each department can be associated with the multiple faculty members, establishing many-to-many relationships. Now create a table with the example of many-to-many relationships from the faculty and the department entities. Here the faculty table contains the rows, faculty ID, faculty name, and the course department, and the department table contains the rows, department ID, department name, department grading, and the faculty ID. Then next, from the above example, as per the business logic, we can see that the faculty works in more than one department and vice versa. It is also true that the departments have the multiple faculties working with them. Now if you see it technically, then records in the faculty table is associated with more than one record in the department table, and the records from department table are associated with more than faculties or the records in the faculty entity. Then next, SQL query. Now let's see the query for the retrieving the data using the record association from faculty to the department. Entity referencing using faculty ID has the primary key in the query. SQL query. Select a faculty dot faculty ID and the faculty name, faculty codes, department ID, department name, department grading from the faculty, join department on faculty ID is equals to department dot faculty ID. In this query works like the faculty ID matched are present in records of the department table, we will get associated with it, and let's understanding by looking at the output. The next output, the faculty ID represents the department table which will be associated those records in department which have the faculty ID has the same in the faculty table. For example, the faculty ID 61801 and 61801 are associated with department. So the faculty ID is representing multiple departments. Then conclusion. A recap of key points on tables, relationships, keys, and the SQL syntax. Importance of the relationships in DBMS ensures data integrity and the meaningful data organization. Then thank you, sir. Thank you for giving this opportunity.